So this video is a continuation of VSPER theory. In this video, we're going to take a look at molecules that are based on trigonal bipyramidal electron geometry, and we're going to start with PCl5. Now, when you go and do PCl5, you might be thinking to yourself, well, if I look at phosphorus, it's kind of got this structure, so it should only form 3 bonds. Well, when we go and use our process that we learned previously, we count up our valence electrons. Phosphorus has 5 valence electrons. Chlorine has 7 valence electrons times 5, so we've got a total of 40 electrons to place. And we end up with a structure that actually looks like this. Phosphorus with 5 chlorines around it. Okay, and you can count up all these electrons. It should all add up to 40. And the reason for this is that because phosphorus has its valence shell in the third energy level, is its valence shell, the third energy level has access to sp, but it also has access to the d subshell, and an electron will get promoted from the s up to the d and allow it to make 5 total bonds. Okay, so looking at this right here, I've got 5 bond pairs, 0 lone pairs, total of 5, and I got AX5. My electron geometry, so the optimal arrangement for something that's making 5 bonds is this trigonal bipyramidal formation, whereby you have an X coming above and below, this coming forward, and all of this is sitting on a trigonal planar plane, right? So this right here is all in one plane. I'll sketch it out for you right here. Okay, this is all one plane right there, and then you have the X coming above and the X below. So we call this trigonal bipyramidal. Okay, and since there are no lone pairs on the central atom, we just draw it like this. We put phosphorus here, our chlorine, one coming forward, coming out of the page right here, and then one going behind, okay? And then right here, we have a bond angle of 120 degrees, and that is a bond angle of 90 degrees. And again, this is still trigonal bipyramidal. Okay. Now, let's take a look at SF4. If we do the Lewis structure for SF4, we will find the following. It's surrounded by 4 fluorines. If we count up all the electrons, okay, we should have 34 electrons here that we need to place. So we should have 34 electrons. That's based on the 6 electrons from the sulfur, 7 electrons from the fluorine times 4 is 28, 6 plus 28 is 34. Now I've only placed 32, so where do 2 electrons go? 2 electrons go on the central atom, they go on the sulfur. Okay, so bond pairs I have 4. On the central atom I have 1 lone pair, right? Remember, this is always referring to on the central atom. Okay, total pairs of 5, and now I have AX4E, okay, and I end up with this electron geometry. Well, I have my central atom, and what we do is in trigonal bipyramidal, if we have lone pairs, they always go on the trigonal plane, and we can see that rule at the top listed. I'll show you where that is on the first page. Okay, I've highlighted it for you right here. It says in trigonal bipyramidal formations, lone pairs always go on the plane to minimize repulsion. So that's trigonal bipyramidal formations. Okay, so I'm just going to write right here, this is still trigonal bipyramidal. Okay, but when I go to draw this out, I have my sulfur here, my fluorines here. I don't have a fluorine over here. That's where my lone pair is. And then I have a fluorine going backwards, one coming out of the page. And as you may have guessed, this lone pair is going to push along the bonds in the plane, and it's also going to push on the bonds coming above and below the plane as well. which makes this less than 90 degrees and this angle less than 120 degrees. If we tip this over on its side, it actually looks like a seesaw, okay, or a teeter-totter. Either are acceptable. Okay, moving on to the next one. CLF3. So effectively what we have is we have Cl in the middle. We have it surrounded by 3 fluorines. Okay, and they have all their octets completed. But chlorine now has 2 lone pairs on there. So we have 3 bond pairs, 2 lone pairs. Again, the total is 5. It's always going to be 5 in this section because our electron geometry is trigonal bipyramidal. We have AX3E2. And remember that lone pairs, again, have to go on the trigonal plane. So what I'm going to do is I'm just going to reorient this. And now, instead of putting my lone pair out here, and then like one over here, I'm just going to put my lone pairs over here. So I'm going to put them on the plane, right? Okay, so they're here. They're on the trigonal plane, but I still have an X coming forward here, okay? So again, electron geometry is still trigonal bipyramidal. And then in this case right here, I have my chlorine, and then I've got my fluorine here, and I've got my fluorine here, and my fluorine here, okay? And as a result, this one right here is going to have less than 90 degrees, right there, a less than 90 degree bond angle, right? And this is actually called T-shaped. Okay, moving on. So this is I3 negative, so I've got 3 iodines here. These have their lone pairs around them. Okay, and then I'll have 3 lone pairs on the central atom. All of that's negative, so now I've got 2 bond pairs, 3 lone pairs. Okay, again, a total of 5. AX2E3. And again, in trigonal bipyramidal, I'm always putting the lone pairs on the trigonal plane. So I'll have I've got a lone pair going behind here, a lone pair coming forward, and then a lone pair still on the plane. Then I have an X coming top and below. This is trigonal bipyramidal. Okay, and as you may have guessed, we have iodine in the middle, iodine at the top, iodine at the bottom, and all of these 3 repulsions are balanced out. So we have 180 degrees, which gives us a linear molecule. Okay, so these molecules, as you can see, what they have in common is that they're all based on trigonal bipyramidal electron geometry, but their molecular geometry will change based on the number of lone pairs that we input into the molecule. So the next video that we're going to take a look at is families of molecules with an octahedral electron geometry base.